Hello. Hello, hello. Good morning. G-Man. Fuzzy, I'm doing good today. I'm happy that we got to skip Monday. Happy we got to skip Monday. Good morning, YCS. Welcome. Good morning, Uchu. Good morning, Brandon. Welcome. Probably didn't spell it right. After today, good morning, Top Wolf. Good morning, Yang. Welcome. Welcome to the stream. Got some early birds today, I see. Good to see you guys. I'm going to turn this off, I think. Yeah. Ed Jorgensen made that overview video, and he was using like the standard Mac microphone or something. It was super hard to understand him. So I will cover it myself. I'll give you your own little overview so that you don't have to watch that if you don't want. Whenever the assignments do come out and after we've completely covered the material, I will run the program in front of you guys to show you how it works. I assure you, and I did say this on Thursday, that I'm going to upload it, but I also said that I didn't cover the material for it. So there are some people who got started, but I promise you guys that I fully warned you that we hadn't covered that stuff yet, and that I would extend it if necessary. Now, don't get me wrong, the assignment is super easy, I promise. There's just a few things you need to understand. And Uchu, I think you're right. There are a few students in here that came from, say, a different class like Java. And I just wanted to get it up there. There's also some students who learn better on their own. They don't always come to class and stuff like that, but they can just do this amazing Google research. So I just wanted to get it up there for the people who wanted to try it. But yeah, we didn't really go over we covered a little bit of that, but not most of the assignments. So we're going to be doing that today. Given that we've only got so much time to do so, and it is 11:30, I will not really be reviewing the notes. So I'm kind of just jump back into classes after we finish this part. But I will be coding a brand new example today, starting from scratch. So you'll see me get started all the way from the beginning. All right. So the first thing to cover is obviously assignment 2. You can see the notes are up there, okay? It has been posted. Some people have got started on it. I will extend it if necessary. But after today, you should be able to do it. All right. And I will cover it when I can. If I don't get to it today, I'll just have to make a YouTube video sometime today, little 10-minute video or so, just talking about the assignment, so that you don't have to watch the one that's already there. Like I said, the guy was using a terrible microphone, and I couldn't even understand really what he was saying. But that video is there if you want to watch it. It's a fun one. Like I said, it's pretty easy. We're coming back to Deborah, huh? Perhaps. Perhaps. Coming back. This is gonna be a running joke for the remainder of the semester, Deborah. All right. So the first thing we're just going to talk about is the header and implementation files. This is something you've never done before, but it's not very hard. It's not very hard. So it's just kind of, you need to think about how in the real world, programs are going to be organized in more than just a single file. If that was not the case, your main files, your like CPP files would be like 500,000 lines long. I mean, if you think about some of these programs out there, there's tons of classes, tons of functions, and they're all segmented into their own little thing. And so this is where we introduce the idea of different files. In Java, each class has their own file. In C++, we have all these things called header and implementation files. So we're going to be going over that today. For assignment 2, you need to do a header and implementation file. Once again, it's not very hard or scary. It's just putting your stuff in a different place. All right. So the way to think about it is, what is the header file? Whoops. I'll turn that down. The header file is just like your standard libraries. Now, you guys are always including things like IOStream. Let me kind of pull up our files here just to get started. Now, I've made 3 files, and we'll get into them in just a moment. You can see them there. Today, we're going to be making a class for a 2-dimensional point. This is, I think, one of the easiest examples to understand when we start to learn classes. So we're going to be doing stuff with 2-dimensional points today. But first we're going to start with main, and as we said before, you're always including things like IOStream. Now, you can always include a bunch of different stuff, and if you come in here and look through some of the stuff that IntelliSense recommends, you'll see here there's these things called .h files. Now, these are just libraries. So IOStream is a library. In some sense, we're importing a header file here. If you go and look at some of the stuff that's imported from assignment 2, you'll know if you read that there's a little bit of randomness involved with that. Let me go ahead and just black this out real quick so I don't ruin anything. Okay, here we go. You'll notice here there are some libraries included. These are from C. These are from C, not C++, and you'll notice that they are .h files. So pretty much all the functions and classes are reachable through these .h files. So those are header files. All right. So what goes in the header file? Well, I know that most of you, we at least talked about it, remember from CS 135, that we would put all the function headers and maybe struct definitions above main, but we wouldn't include any function definitions above main. So what goes in the header file? Well, we'll put in our function headers. I call them prototypes. All right, these are the headers. There's no code that goes in here. No code. And also what goes in here are class or struct definitions. The class definition goes in here. Definition. You guys know I suck at this, right? I got it right. But the member function definitions are not in here. Only the prototypes. All right. So that's what goes in the header file. And so then you might ask what goes in the implementation file. I guess I should put a definition here. headers for code. What is the implementation file? Well, this is the kind of the, I mean, you guessed it, right? This is where we put the definitions for functions. And so when we're ready to use these things, we just bring them into main. So let's say I declared, say, some point2D class. I declared a point2D class, and I wanted to use it in main.cpp. The first thing I need to do is include whatever the header is. It also needs to be in the same directory. Include the header file, which is in the same directory. And so that's going to be something like include, and then you're actually going to put it in quotes, since this is we're defining it ourselves. It's not included with C++ or the standard template library. So whatever we name it, likely I've called it point2d.h. So you saw that, some of you, in that file there. If you go look at assignment 2, if you look in main, you'll notice here's this include 26.h. So you're going to be putting your code in this file. You're going to be putting some code in this file. So that's kind of how that works. Like I said, I'll be giving you an example of that today. Now, how do I compile it? With an implementation file, a compilation is a little different. Yeah, so a makefile, I will get to that when we can. I'll put a little note about that, and I'll talk about it when I talk about the assignment. But all you need to know is that's what you need to compile your code. We'll spend a little bit of time on makefiles in this class, but it's not our main priority. Make does make your life a little bit easier. So let me go ahead and finish these notes, and then I'll get to that just briefly. Is a little different. So for every implementation file, it must be included in the compile statement. So in our example today, we have point2d, the header file, which is point2d.h. Then we have the implementation file. I'm just going to copy it at this point. It's a big word, and I get scared every time I type it. We have an implementation file here, and so that's actually going to be point2d.cpp. So all of the prototypes in the class will go in this file. The function definitions will go in this file, and then we'll have the main file, which is just main.cpp. So if we want to compile this, it's going to look like this, where we have g++ -std equals C++11 main.cpp, and then we're going to list the remainder of the implementation files here. So point2d.cpp. All right. We'll even make a little makefile just for fun to show you. Let me go find one of my old ones so I can just edit it right off the bat here. So what is a makefile? This is a file in Linux where we can put the compile statement for your code. All right. And so every time you want to compile, you just type make. Yeah, we're talking about Linux, which is a C++ class. So like I said, we're not going to spend a whole lot of time talking about makefiles. Even I only know the basics of makefiles. And Ed Jorgensen, the person who made the assignment, His makefile is very advanced, almost too advanced for me, a mere grad student. So, like I said, I'm not going to really tell you what's going on in there, but I will show you how to make a basic makefile. Okay, that's coming up here. Whoops. I had a little bit of a lag there, I think. So please refresh if you need to. And I will be moving our makefile into here. All right, so I've got a makefile here. So as I said, a makefile, all you have to do is, well, let's see here. I'm still live. Yeah. All you have to do is kind of type this all thing and then put whatever your compile statement is. So for example, today we talked about this. This is your compile statement here. And so in the makefile, you have to put that compile statement. You also need to name it makefile. Notice it's got this pretty M. That M indicates to Linux that this file is for a specific purpose. Now the makefile from the assignment, I wouldn't open it, okay, because it is confusing, but we will use this today. And whenever we want to use the makefile, instead of typing the command, the G++ command, you just type make. Super easy, not a problem at all. All right, and the reason these are used are specifically for implementation files, because some implementation files may change and others may not. So when that happens, you don't need to compile the whole code all together at once. Rather, you'll just compile the new stuff. Pig, the thing is, you can't have two files with the exact same name in one directory. That's not allowed in an operating system. So there cannot be multiple makefiles in one directory. If you tried to make a file with the exact same name, the operating system would stop you. And Mail asks, so make is kind of like the a.out. No, but it's like the G++ statement. You replace make with the G++ statement. Instead of typing the G++ command, you type make. And that makes the ./a.out. Pig, I don't think so. I think it needs to be named makefile. I think it needs to be named this. This is the required file name. That's how Linux knows what you're talking about. And do you include main.cpp after make? No, you don't. For the assignment, you don't have to make the makefile, by the way. It's already included. But this is the this is the Linux statement. So instead of typing the Linux statement over and over again, you just save it in this file, and then you type make. Notice that main.cpp is already included here. And then in the case of our implementation file, we're also going to include it there. So let me get to some example here so you can see it in action just to show you what it does. All right. So we're going to kind of catch ourselves up here with classes, okay? Like I said, I'm going to give you a nice example here. So just give me 1 second to get that all said and done. So here are all the notes from classes last time. We did talk about that, and so you can review it if you want. Synthos asks, if you have more implementation files, that could be included in the make, right? That is 100% correct. For every single implementation file you have, it must be included in the compile statement. So that might look like this, for example. Let's see, where's our compile statement? If there was more than one implementation file, it looks like this. Where they're just continuously included at the end here. Does that make sense? So for every CPP file you have in the program, it's going to be listed here off to the side. All right. So you're 100% right about that. Whoops. But in today's example, we're only going to have one. And in your assignment, there's only one. In your assignment, you've got the 26.h and the 26.cpp. Like I said, the make file is included for you. So it's really not a huge deal. Meaning you can just you don't have to make the make file. This is all new and stuff, so I don't expect you to be a make file master, like I said. But I'm just letting you know that it's there, and that's what its purpose is. So let's go ahead and get our favorite stuff in here for a program. Now this is only for main. So for the most part, I'm not even going to include any functions in this file at all. All right, there's going to be no functions in here at all. But in here, I want to be able to declare, say, point 2D P1, something like that. Point 2D P1. Chef asks, does your code go in both 26.h and 26.cpp? The answer is yes, it does. The headers go in the .h file, and the definitions go in the CPP file. So in order to declare, say, some point 2D, I need the class definition somewhere, right? And so normally what you guys do is you would come up here and you would say, hey, I need this class here. I'm going to call it point 2D, and whatever I put in here goes here. Notice this should turn green now because we have it defined. But I said that we're not going to have any classes or functions in this file. We're actually going to put this in the header file. So I'm going to Control X this, come over to the point2d.h, and this is where it goes. So there's one thing I am going to do. I am going to include some stuff up here. Maybe I won't. We'll see. The one thing I will do is put this. This isn't another CPP file, so I will use the namespace just in case we want to print some stuff. All right? And if I'm going to include something, I can. You just have to keep in mind that there may be some problems. And here's one issue with that. Is let's say both of these files include IOStream. You're immediately going to have an issue here. In that if I bring in now my new header file, so notice here that the point2D, it's still white, meaning I don't know what this is. I don't know what this is. In the moment that I include my file, and remember how I said we have to put it in quotes. As soon as I include this file, this should hopefully turn green in just a moment. Let me make sure everything is saved here. Jeez. My computer is having a rough time today. All right, so here's our point 2D. Notice that it changed color. So the moment that we included that header file, we were able to bring in this definition. Now the problem I'm saying here is that IOStream is included in both of these things. IOStream is included in both of these things. So let's actually just pretend to go compile it real quick. Let me put some comments here for you to reference. Just in case when you come in here looking for examples. This is our header file. All right. Now we're also going to have a definition file, an implementation file. That's the CPP file. And we're actually not going to put anything in there yet. All right? Because we don't have any functions yet. We only have the class definition. The class is blank, but it does exist. All right? So this is our CPP file. Now, since these are two different files, we do have to include the header file in the implementation file. So let's add that. Now this is all taken care for you in the assignment, all right? I already included the libraries. You don't really have to worry about including any libraries. All right? Don't have to worry about it. But in here, I need to have this CPP file here, point2D, needs to be able to communicate with this H file. How's it going to do that? Well, it's going to do a nice include statement, just like normal. And you can actually just copy it from main, is what I would do. And I would also keep the std there, since it's a different file. So the moment I include this, now this implementation file is connected to the header file. And you'll notice down here, I should be able to reference some things. Let's go ahead and add some variables real quick before we try to compile. Remember, we talked about private. What does it mean for a member to be private? Can anyone remind the class what it means for a member to be private? And let's say I make it public for just one moment. Cannot be accessed outside the object. That's a fair definition, right? Only members inside of the class can access a private member. That's correct. Now let's say I make these public. Down here in the CPP file, I should be able to declare, say, something like a point2D. And I can access things within it, all right? So we know that these files are now connected, and that's because I included it here, all right? So like I said, I'm going to go try to compile this, but I will show you that there is an issue. We're also going to test out our make file, all right? So let's go ahead and restart Bobby here. Wake him up, and we'll drag our files over. Is the stream doing okay? My computer is having some hiccups here, obviously. Are you guys noticing, is it unbearable, or you guys can still understand me pretty well? How did this get in here? Okay. Thank you for telling me. I don't know what the heck is going on with my computer today, but it is totally not letting me do things. I might do a quick restart here of some stuff. All right, looks like things are moving on here. Yeah, it's Deborah. Deborah is what's going on here. Now, hate is a strong word. We'll just say that we dislike Deborah. We don't want to be too mean here. All right, so notice that we're going to compile this, all right? And like I said, we've got all these files, right? So we're going to type our regular G++ statement -std equals C++11, all right? Now we're going to type main.cpp like we always do. And then we're going to type the implementation file, which is a point, say 2D here, .cpp. And it did compile. That's interesting. That is very, very interesting. Well, maybe we won't have problems, though I think that we should have some issues. Let me just look at this. Now, the thing is, I've included IOStream twice here, which is why I'm a little concerned. But let's see if I can break it. And maybe the compiler's just smart enough to know what I'm talking about. All right. I got to do a quick restart of this stuff. It is not happy today. What's going on here? So my connection is good, but Visual Studio and MOBA have been running probably for the last 2 days or something like that. So they're like, they're basically telling me that they've been awake for too long. Does the implementation file in the header make sense? You understand where things go? Like I said, I'll be kind of coding that stuff up today. Cool, thank you. What is this? Can you guys let me know when you're back, please? That wasn't Twitch. That was my computer. That was my computer. Yeah, my computer's like getting old or something. I don't know. You guys are all back? Thank you. And my computer just died. My computer just died. I don't know what's going on with it. So we're gonna try to keep it going here today. And I'll be looking into why my computer thinks that this is an appropriate time to do this stuff. Maybe download more RAM. Yeah, I'll work on that. I'll work on that. I need a UNLV Chromebook. I don't know if a Chromebook will have enough power to stream and make videos. All right, we're back. Let's continue on. My computer literally just decided to cry. All right, back on track here. Back to focusing here. Everything's restarted, all nice. Everything's nice and fine here. And I'm going to try to compile this. Again, now as I was saying, if we want to compile something, we usually type this statement. But if we have a makefile, we can just type make. And it will run whatever is in the makefile. So notice that that is there. So for assignment 2, whenever you want to compile, just type make. Just type make again. Wow, it's so easy. You don't have to type out that horrendous G++ statement. You only have to do it once. All right? So that's what the makefile is doing. Now, it does appear that C++ has advanced itself. And it understands that if I include IOStream twice, it's not going to get mad at me for any reason. All right? Are you still having problems, Pig? Is that what's going on? All right. So let's go ahead and make our point2D class here. Let's see here. Why will you not accept that? Please accept this. Man, I'm really having issues today. I'm really sorry about this, guys. I don't know why. I really don't. I've never had issues with this. I thought I was a computer scientist, but apparently I'm not. Okay. So, let's go ahead and get started with our point2D class. We have to talk about some things. All right? So, where did we leave off last time? Well, we talked about just some basic stuff. We talked about the access modifiers, and then we began talking about member functions. What is going on here? Okay. Yeah, the duplicate libraries, I'm not sure what's going on there. Just be aware of it, okay? I think that's a fair assumption, is that if you're including IOStream in 2 different places, just be careful about it, okay? Just understand that there might be a duplicate library somewhere. For your assignment 2, I kind of protected them with these things, and I'll try to talk about those when I talk about the assignment. You'll see in there, there's like a define thing, an if, endef, and end if. All that stuff, don't touch it, don't worry about it. That's just trying to protect you from compilation errors. All right. So now back to our class stuff. We talked about private and public, and we talked about how there can be functions. All right. So a function in some point2D class might be calculate distance, right? So let's go ahead and add that in here. Before we do that, though, maybe we'll just do a nice set xy function, a nice setter function. Set xy, int x, and int y. Now, as I showed you in the last class, I could put the code here for this. I could say, hey, let's go ahead and make, I'm going to rename these just so they use different names. I could come in here and I could say, hey, x is equal to x1, and I could say y is equal to y1. And then it's good to go. There's no problem here. The code is already in the class. But for your assignment, I'm asking you to put the code in the implementation file. So how do we do that? Well, let me kind of go out of order here just a little bit. Maybe not out of order, but underneath the member functions notes here, we're going to talk about how do we put the definitions for member functions outside of the class. Well, pretty easy. We need to use something called the scope resolution the scope resolution operator. Pig, I'm going to ask you to be patient with me on the reasons for that. We did kind of talk about that last class. Why would we restrict access? So you can review that if you want, but you're just going to need to be a little patient with me on that because there's a very good reason to do so, especially when we get to dynamic memory. A good example to think about is with strings class. You guys can hear me, I imagine. I'm sure my face is just... oh my gosh. What is going on here? Alright guys, as I said, we're just going to have to deal with this today, okay? We're just going to have to deal with my terrible connection, and I'll work as best I can to fix it for next class. For now, I'm just going to need you guys to just let me know when you lose me, and we're going to do our best to deal with this just for today. I know that this is unexpected, and I am sorry about it. All right, just let me know, like I said, when you lose me, just like you did, and I'll come back as fast as I can. All right, so how do we put the definitions for member functions outside of the class? Well, we use this thing called the scope resolution operator. That looks like this. It's 2 colons. And so whenever we want to access something inside the class, we either need an object or the scope resolution operator. No coder left behind. Please stay with me here, okay? Whenever we want to access something inside the class, we either need an object or a scope resolution operator. So let's do an example of that. When using the resolution operator, I'm going to call it SRO. When using the SRO, we need to put the name of the class and the SRO. So let's get an example of that. So say somewhere I have class, I'll scream it, class my class. And in here, I have some function under public called void foo. Now, if I want to access this outside of the class, I want to put that definition somewhere, I need to first type the name of my class, and then use the scope resolution operator to go into the class and pull out foo. And then I can put some code here. Now, the thing is, we're also going to need to include the type of that class. And I'll kind of get to that in just a little bit, or the type of that function. Notice that this function here is void foo. So just like in CS 135, when you declared your headers and your definitions, we're going to have to do the same thing here. When referencing the name, though, you're going to need the scope resolution operators. So I'm going to show you that now. So I've decided that I want to put this function outside of the class. So I'm going to take that body away. I'm going to come in here. Now, what's the type of this function? It's a void. So I'm going to type void, and then I'm going to do my scope resolution operator, .2d, and then I'm going to put the 2 colons, and notice it will let me know, if your IntelliSense is smart, where we're going. So I said I want to do the setXY function. This setXY function takes x1 and int y1, and the body of the code can go there. All right. So did that make sense? That the function, the member function header goes in here, and we can just leave it here. And then if we want to put the definition elsewhere, we can do that, but we need to kind of just include this little bit here to get to the name. Because if I don't do this, I basically just declared a regular function. If I don't include that scope resolution operator, this thinks that I'm declaring some global function here. Some global function. And notice that it doesn't know what the x is. It also doesn't know what the y is. So, if I want to access, if I want to make a definition for that function in the class, I just have to include this scope resolution operator. Now, I gave you an example of that in the assignment. All right, I gave you an example of that. You can kind of see it there in the CPP file. Now, Uchu asks, if the function is private inside of the class, would it be the same process? Now, yes, that is true. So here's what I'll say. This is a function definition, i.e., it's not a function call. It's not a function call. All right, so it doesn't matter if this is public or private. Now, if I tried to call, say, a private function from main somewhere in here, then I'd have the problem. But just because this is the function definition, this is just the function definition, it doesn't matter whether or not it's public or private. We're just putting the definition for that outside of the class. So now, as you can see, we've got some code here. Let's add another function and let's kind of do a nice example. Let's add some code here and do a nice example. I'm going to do something called a void print point. Let's actually do a string. I'd rather do that. And for this one, can anyone tell me if I wanted to declare the body of this, if I wanted to put the definition for this function outside of the class, what is the first part? Down in this header file, what am I going to type here? So I want to put the definition here. So what's the very first part? What's the header going to look like? Basically, I'm asking you to type this portion of this code, but for the definition, what would that look like? How do I put it in the implementation file? Yeah, we use the scope resolution operator. That's right. I would say chef is closest, right? The first thing we need is the type. And then after that, yeah, the type, you're right. The string comes first. And then we'll go ahead and put a nice .2d here And what do you know? We're inside of the class again, right? Yeah, you guys all got it. Synthos and Top Wolf, you're right. Pig, you're right. That's exactly how it works. And in here, I'm just going to say make some string. And it's going to be my return string. And I'm going to want to convert these things to a string. So I'm maybe going to include something up here as well. Maybe not in here, but rather in the header file. Like I said, I may want to include some things. And let's say there we go. Let's say I want to return this return string, but first we got to put some stuff in here. So I maybe want this point to look like this, XY. So I'm going to say that the return string maybe is equal to this, say plus 2 string the X plus, I'm going to go a little bit vertical here, say a comma, and then plus a 2 string Y, and then plus maybe a close paren. All right, so that's a nice little function we got there. So let's go ahead and test our stuff here. So we've got our function definitions in the implementation file. We've got our headers in the header file. Look at how nice this is, by the way. Yeah, you're right. There is a 10-second lag. We're just going to deal with it because I want to keep the YouTube video all together. So I will be patient with you guys. So notice how nice this looks. The definitions aren't here. You can see exactly what this class contains. And the definitions are all packaged in this file instead. Now in main, what will I do? Well, I can only access public things from this function. So I'll call setXY and then I'll call, say, print point. So the first thing I'll do is I'll say, hey, let's go ahead and set XY in this to maybe 1, 2. This is a two-dimensional point. There's an X and a Y axis. And then let's say I wanted to print it. So that will be P1 print point. Now that I'm realizing something, I really don't want to call this print point. I'd rather call it something like toString. Since I'm not actually printing it, rather I'm just returning a string, I'm going to call it that. I hope you're okay with it. I think it does make a little bit more sense. So let's go ahead and give this code a run. Now, that did not look good, did it? Here's where my computer dies. Let's see if it survives. Woo! It lived. All right. So the first thing we're going to do is type make, right? That's the compile statement. And if we run it, look, we get a nice 1, 2 here. Now I'm going to ask you something very important. I want to see how many people understand this. Let's say I declare a point 2D, a second one over here. And I declare this, say, 3, 4. And then I do P2 to string. We know that this is going to print, this one prints 1, 2. On line 14, what are we going to see? What are we going to see from the output? What is going to print on this line? Can anyone tell me? What is going to print on that line? We're introducing the idea of having an object here. We're going to start talking about something called the instance variables and the static variables. I've got a question here from Synthos, asks, we need to include CMath. We have the library in the header file. If you're going to be using CMath inside the class, I would say yes. If you're going to only be using CMath inside of main, then I would include it in main. So Uchu says 1, 2, Kate says 3, 4. Now this is why I asked this question. And Pig says nothing. We'll talk about the static variables. So we're introducing the idea of objects, right? So Giovanni, you are correct. Oh, whoops, I made a mistake. Guys, I totally made a mistake. We would see nothing. Pig is actually right. Yeah. Pig is right. Chef and Pig, you're totally correct. You're so right. But let me kind of describe this to, say, Uchu and Cade. And Cade, I guess, kind of thought maybe a little bit about what I was doing. These are different objects. This is a different object than P1. So P2 has different X and Y than P1 has. So P2 and P1 are members of the same, they're objects of the same class, but the way we have to think about it is each instance, and when I say instance, I guess I should define that for you. What's the best way to put this? Let's see here. We call this an object. Each object, it's exactly like a struct, right? Each object is an instance of a class, all right? Each object is an instance of a class. So in this sense here, though I totally messed it up, I always do, P1 is an instance and P2 is an instance, which means each instance of this class has their own X and Y. So when I call, say, set XY here on P1, I'm talking about P1's X and P1's Y. When I call set XY, here I do it, set XY on P2, I'm talking about P2's X and P2's Y. P2's X and P2's Y. So when I'm talking about X and Y in here, I'm talking about what belongs to the instance of the class, what belongs to the object. So all variables and functions are considered instance unless specified static, all right? What does this mean? An instance variable, each instance of a class has their own set of instance variables, all right? So that was the point I'm trying to make here. I'll go ahead and compile it for you guys just to show you that P2 and P1 are different objects. So P2 has its own X and Y and P1 has its own X and Y. So the output, we should see, if I got it correct this time, we should see a 1, 2, and then a 3, 4 afterwards. So I'll type make. I'll, of course, run this code. And you notice that P1 and P2 are different objects. They are different objects. Now, we're going to talk about probably static variables next. Well, let's see here. I kind of want to get to the stuff that's in the code. I guess it doesn't matter. A static variable or function is shared by all objects of the class. Pig asks, point 2D P1 and P2 is similar to string S1 and S2. Yes. I know you've declared multiple strings before. And each string contains its own stuff, right? So we have a good question here. Synthos asks, does P2 make a copy of the class? Well, here's how you think about it. This is a blueprint. This is a blueprint. This is a skeleton. So just as example, we could have a class person, and I am an instance of that class person, just like you guys are an instance of that class person. Now, the thing is, we all have a skeleton, So we all have the same 207 bones or something. Once again, computer science major. So if I got that wrong, I'm sorry. But guess what? Some facts about me. I'm a giant, okay? I'm 6'7". I weigh 300 pounds. You likely are not that big. So we reference our blueprint here. The blueprint says I have 207 bones. And so I'm going to get probably a variable for each of my bones. But that doesn't mean we're going to share the same values. Most of you, some of you probably weigh less than I do. Some of you are maybe shorter than I am. Some of you are maybe taller than I am. So this class is the blueprint. And so whenever we declare a point2D in main, it references the blueprint and it says, what am I made of? It says, what am I made of? And it says, well, I'll go reference the blueprint. I'm made of one X and I'm made of one Y. So my instance variables are this X and Y. For example, in our person class, our weight, our age, our height, those would all be instance variables. We have a blueprint that says we have all of these variables. Everyone has a weight, a height, but that's just in the blueprint. Those values are likely different. Did that answer that question, Synthos? It kind of makes a copy of the class, but rather this is just a blueprint. This is instructions to tell us what we're made of, basically. To tell this point here, what are you made of? So you're saying we all reference the same class blueprint, but we send over different variables. That's correct. P2 and P1, just like people, P1 and P2 have their own X and Y, but the X and Y's probably contain different values. P1 is 1, 2, P2 is 3, 4. So those are instance variables. Those are the instance variables. These are different instances of an object. This is instance P1. This is instance P2. Yeah, it's like a format. It's like a mold, sort of. They're different instances. Now we're going to get a little wacky here. A static function or variable is shared by all objects of the class. Static meaning it has one memory location. So static variable or function has own memory location. Pig, you say, in my mind, we're creating a data type. That's exactly what we're doing. We're making our own data type. It's a user-defined data type. So, usually, what is this for? This is counting. Usually, we're counting the number of objects in a class. Something like that. So let's talk about static variables. So an example of that would be static int variable. I'll call it memvar. All right. So I'm going to make two static things for this point. Now I'm kind of rushing here. I do apologize. But I kind of want to show you what this looks like. So I'm going to make them public, meaning that they're accessible to everybody. Well, maybe I won't. Maybe I will. Maybe I won't. We'll start with that. The first thing I'm going to do is I'm going to declare a static int point count. All right, and this is to keep track of all the objects. Okay, that's to keep a running count of all objects. I'm also going to declare a static function, distance function. This distance function is going to take the distance between 2 points. So I'm going to call it, say, static. I think it'll be maybe a float. Distance between. And what is this going to take? Well, it's going to take 2.2Ds. Now, these are static variables. These are static variables, meaning that, or static functions, meaning that they are shared. All objects will share the same variable. So this is an instance. Instance vars, right? Each instance of a class has their own X and Y. They also have their own setXY and own toString. So these are instance functions. But the statics down here are shared by everybody. So I'll show you that. So let's say every time we create a P1, we're going to go ahead and say that the point count goes up. Now there's two things we need to do. For one, we need to initialize this value. All static variables must be initialized outside of the class. Outside of the class, which is usually global. All right, so let's do that. So in point2d.cpp up here, I'm going to initialize my static variable. Now, TopWolf asks, do we need a pointer to access static type variable? I'd be careful with the use of the word pointer. We're going to be using that later on. So I wouldn't call it a pointer, but we do need a scope resolution operator. So if I do this, I say point count equals 0. I've just declared a global variable this way. I've just declared a global variable. But I say, no, I want to be talking about this one. So in order to access that, I need the scope resolution operator. So that's how we initialize it. That's how we initialize it. So a good example of that would be, say the type, and then the class name, scope resolution operator, var name is equal to, say, 0. All right, equal to some constructor. So if I say that it's an int, then it's going to say this is equal to 0. So hopefully that answers your question, TopWolf. You need the scope resolution operator. So now in main, whenever I want to access it, I'm going to say, hey, point2d, point count, plus equals 1, right? We've increased the number of points. And here we'll do the same thing. The number of points has been increased. All right? Now, this is a little confusing. But you can access this from an object, but I hate this because this is confusing. Now this point count is shared by all objects, but we can access it from objects. Now the reason I hate this is because it makes it look like the point count belongs to P1, which is not the case. It's not the case. It actually belongs to the whole class, so I always prefer to use the scope resolution operator. All right, so I can see out this value, number of points in our program. After we create each object. I don't want to put it there. Does that make sense? That anything static is shared by all of the objects. All of the objects share the static variables. The instance variables belong to each object, but the static ones are shared kind of globally almost. Every instance of the class has access to that one variable, but there's only one of them. All right, this might help it sink in a little bit. Like I said, this is confusing and I don't like it. But look, if I said P2 point count here, and I said P1 point count here, I will get the same output. Like I said, I hate this, right? But we're going to get the same output because that variable is shared by all of the objects. Same output. Yeah, the static variables belong to the class itself. Yeah. So we'll have plenty of practice with statics, all right? But that's what a static variable is. There's things called instance variables and things called static variables. Now we need to talk about probably the most important thing that you need for your first assignment here, and that is a constructor. I will come back to that static function in a little bit, But just remember that a static variable or function is shared by all of the objects. Now we need to talk about something very important just so you have enough information to get started on your assignment. Of course, we had all these hiccups today during class. The world is out to get me. We had Labor Day off. Apparently, my computer also took Labor Day off. And it was just sleeping today. So I'm running out of time here, so I need to talk about probably the most important thing called a constructor. So what is a constructor? A constructor is I'm going to call it a function-like body of code that is executed every time an object, I'll say instance, of a class is created. So you cannot, the only way you can call a constructor is to create an object. So here's my question for you now. Have you guys ever created a string like this? I know that you've declared a string like this before. String my string. Now we just declared a string here. Now this is a class, so I'm just going to let you know a constructor gets called. Now can anyone tell me what this one does? What does line 27 do? Does anyone know? And have you done it before? I know some of you maybe have done it before. What does line 27 do? Or what do you think it does? It's kind of my question for you. What do you think it does? It defines it, right? So this string here contains nothing. It initializes, Klaus is right, it initializes this string with hello. It doesn't print it. It just initializes it. So if I were to print my string 2, I were to say cout my string 2, we're going to see hello. Yeah, I guess some of you maybe, yeah, there's a huge delay. I totally get it. I know. I'm sorry. We're persevering. This string is initialized. So look, it gets initialized. How does it do that? Now, some of you, like I said, have never seen that before. Why or how is it doing that? Well, this is calling a constructor. This calls a constructor. And the constructor usually initializes the object. That's what it does. Constructors are used to initialize the instance. There can be more than one constructor. As long as they have different variables, long as they have different parameters. Now, what does that sound like? Can anyone tell me? What does that sound like? They can have more than one as long as they have different parameters. What does that sound like? And while I'm waiting for the 40-second delay here, let me also talk about this. How to declare a constructor. It's just the name of the class. All right, so constructors have no types. Just the name of the class. Function overloading, right? That's exactly what I'm talking about. It's like function overloading. It's just the name of the class and the list of params. So if we had an example of that, that looks like this. It's just my class. Params. All right, are you ready? We're about to learn something. I'm about to learn you a thing or two. Let's make some constructors. Constructors can be, usually constructors are public. Usually constructors are public. So, point2d, this is our default constructor. And then we're going to have another point2d. This is a different constructor that takes an int, say x1, and an int x2. I like to call this the parameter constructor. Parama. Default constructor and parameter constructor. Now, these get called whenever an object is created. Now, I'm going to go ahead and define them in the implementation file. Like I said, they have no type. In a sense, they return their own type. I'll kind of put that here. They return an object of the class. That's what they do. So point2d, point2d. Isn't that gross? I'm talking about the point2d default constructor that's within the point2d class. Are we confused on that? That's the default cons. And let's talk about the param cons. Looks exactly the same, except this one takes an int, say x1, and an int x2. Now I'm going to do a little print statement here that says default, or cout, default. All right. And in the other one, I'm going to do another little print statement that says this is the param. This is the param constructor. And let's say in the default, we want to initialize some things. Let's say that the x should be 0 and the y should also be 0. And notice how in main, I've been doing this point count stuff. Notice that I'm doing this point count stuff. Instead, let's put it in the constructor where it belongs. So we don't even have to worry about it. All right, now this one, the parameter is almost the same, except we're going to initialize the x to be x1 and we're going to initialize the y to be y1. Yeah, specialized. That's a good word. That's a good word. That's a good word. I like it. Let's see where I call it. Specialized. Specialized constructor. All right, CTOR, whatever you call it, that's what it is. Sorry, I make typos here. Yang asks, what type is the X and the Y? Well, come up here and look in your header. Here they are. Each point2d has their own X and their own Y. They're integers. So every point2d has their own X and their own Y. And so in here, what are we saying? Let's see here. So notice I'm doing the cout statement here. Now it's white because it doesn't know what it is, and the reason for that is because of this IO stream. It's not included. So I'm actually just going to put it up in here. It should be fine. And that should fix my little cout here. There we go. So hopefully that answers your question, Young. Now this X and this Y belong to whatever instance we're talking about. So let's do an example of that in main. So I'm actually going to take this stuff out. And I want you to guess the output of this program. So point P1, I'm going to leave it as is. Point P2, I'm going to declare this as, say, 3, 4. Now P1 calls the default constructor. Why is that? Why is the default constructor called here? What are your ideas? Why is the default constructor called here? And this one is the specialized constructor. I'm going to keep calling it the param constructor for now. And why is the parameter constructor called? What do you guys think? While you're answering that, I'm just going to briefly check the assignment real quick, just so I make sure I've covered almost everything that you need to know. Let's see. So Giovanni is right, and Synthos is right. There's no parameters passed. There's no parameters passed. So it says, what constructor am I looking at? I say, hey, I'm looking at this one. Now this one says, there are parameters provided. So I'm going to go find the one that matches that. I'm going to find the one that matches that. Where's the one that matches that? It's this one. It's this one. So, Yang, you're right. Klaus, you're right. Chef, you're right. Top Wolf, you're right. 0, 0. The next one will be 3, 4. And guess what? The point count is being incremented here. The point count is being incremented. So we're going to see everything. Everything is working nicely. Yep. Hold on one sec. What did I do? What did I do? Did I not save it? I probably didn't save it, guys. Give me a second here. Something went wrong there. Something totally went incorrect. And I'm not sure what it was. There we go. Ha! Fixed it. Okay. So the default constructor is called. That means everything gets initialized to 0, 0. And now we have 1 point, right? So that pertains to this portion of main. The default constructor is called. It's initialized to 0, 0. And then we have 1 point. The next part, the parameter constructor is called. It's initialized to 3, 4. We print it, and now we have this many points. So let's go take a look. Parameter constructor called, initialized to 3, 4. Points, 2 of them. All right? So that's that. Now we're out of time. We had a bunch of run-ins today. I know I'm just repeating myself. I'm like a broken record. I'm upset with my computer. So I'm just, if you would hang out with me for just one moment, I'm going to briefly just review the assignment. And I just want to make sure that everyone has everything they need. We're not done with classes yet, but we should be done with this bit. We should be done with this bit. You should have enough information to do the assignment is what I'm saying. That's all I'm saying. So I do want you to get started because I want you to practice this. Let me just check. Do you guys have any questions about what we talked about today? We talked about implementation files and header files. We talked about constructors. We talked about instance and static variables. Let's kind of just look at this assignment real quick. I'll show you. I'll just give you an idea where to start to help you get started. All right, I did review this. I did review this assignment. And so just give me 1 minute here. I'm going to quickly go through this. I know we're out of time. I'm really sorry about that. But I'll just give you, this is where we get started. Do you see this? This is the UML. Anything that's a minus is private. Anything that's a plus is public. So in your 26.h file, let's go ahead and pull them open. And sure, I'll release a video later. Just give me 1 second here. I'll only go 1 or 2 minutes over. So I'm really, really sorry about that. I don't like to take your time up any more than I have to. But just to get you started. Oh, I'm glad that I didn't do that. So I uploaded the, I'll make a video, but I uploaded the files on Web Campus, okay? So just go to Web Campus. Let's see here. Just go to Web Campus, go to Files, click on Assignments, click on Assignment 2, and then go to Coding Files. And then look, here's your 26.cpp, your 26.h, and your makefile. And main. You only have to put code in these 2 files. So as I was saying, first declare your class. Anything that's a minus is private. Anything that's a plus is public. Next class, we'll talk about constant. Just copy it. It's not a big deal. And then all you have to do is follow these instructions. Inside the files that I gave you tons of comments, guys. I gave you tons of comments. I hopefully made it easy. I don't know if Web Campus will load this. Look at this. I've given you comments to tell you what to do, and I even gave you some examples. Here's a comment from Mr. P. Here's another comment from Mr. P. All right, so give it your best shot, all right? I will release a video later, just a little more detailed one, okay? So give me some time. I'm going to let you guys go now, so you're free to go. Next class, I'm going to figure out what the heck's going on with my computer. I'm really sorry about that today. As far as I'm concerned, you have enough information to do the assignment, so please get started. Please ask questions. I will extend it if we need to, so don't get all hung up on it. Just give it your best shot. You need to practice a little bit so it's there for you. All right? If there's no questions, you guys can leave. I'll be in office hours. Like I said, I will be making a video. And yeah, that's really all I got for you. Thanks for coming. Thanks for hanging with me. I know it was rough. But next class will be better. You're welcome. Top Wolf, you're welcome. Yang, Sithos, you're welcome. Chef, you're welcome. CS202, you're welcome. Oyman, you're welcome. K, you're welcome. Uchu, you're welcome. Kang, you are welcome. Fuzzy, you have a nice day. I will hydrate. Hamma, have a great day. You're welcome. Yang, you're welcome. Cool, you are welcome. Have a great day. YCS, you are welcome. Thanks for coming. You're welcome, Nicholas. Thank you. Giovanni, you're welcome. Thanks for coming today.